Alright, this is our science fair project. I'm Logan Hall, with partner Deep Shea Ray, and unfortunately our other partner couldn't be here today, but he's Ethan Thing. Alright, so here's our project. It's essentially an exoskeleton for your arm. And we made it out of aluminum, so it was lightweight. It's definitely less than 2 pounds. Our main power source for the servo is a nickel metal hydride right here. And for our Arduino, because it needs about 5 volts, we're using 9.4 volt battery. Alright, so basically how it works is there's a touch sensor right here, which basically works as an on and off switch. We did that in the programming. It's held on by this Velcro ring. The signal from you pressing it goes all the way up to the breadboard and gets registered by the Arduino. And then that return sends a signal all the way here to the servo, which actuates the whole entire arm. So basically, all of these, we decided to make the servo run off of separate power, not off of the Arduino, because Arduino only puts out 5 volts.
Yep.
And so it would severely weaken our arm. So we were using a separate battery for that, and it worked alright. Basically, we have foam padding underneath here for comfort. Velcro straps for different sizes, arms, different thickness and diameter. Generally, it will fit pretty much a general range of arms, but it definitely has the best performance when it's custom fit.
Yep.
So, the overall cost of materials was probably about $40. That's including the nuts and bolts, aluminum bars, foam padding, wires, and other things. More expensive stuff though, like our computer, the Arduino, and the servo. And the servo is probably the most expensive thing on the whole entire arm. It was about $90 to $100. So, original basically idea generated from pretty much just usually with elderly, but anyone who has muscle disorders or diseases and that severely weakens their muscles. And so this was like for lifting everyday objects, and that's just like a heavy gallon of milk that they can't lift up or anything else. And this servo, it has about 555.5 ounces of torque, which is about 35 pounds. And with leverage, it's a little decreased, but it can lift about 20 to 25 pounds overall, which is definitely enough for what our total idea was. But basically, this was once again for a science fair project, and it was just how can we help people with muscle problems, weakness, or any other like disorders. We found out this worked pretty well.
Pretty well, yeah.
And we could definitely add things to it as well. And overall, our ideas was basically using a microchip. It's smaller. We could also get a cover and condense this down.
Make it
we
lighter.
also thought, which would also make it lighter.
Yeah.
It's already pretty light. Add a Wi-Fi chip, which would basically let us use Alexa.
Yeah, for voice command. That's our next goal.
We could also, we were thinking about just trying to get it to be even stronger than it is, because this battery is a nickel metal hydride battery, and it's quite small. It only has a runtime of about 5 to 10 minutes, which isn't very long. And we have a LiPo battery ready to use. It's a 2-cell, 7.4 volt, 5,000 mAh, and that'll give us substantially a longer runtime and more strength overall.
Yeah.
And so what we need to do that is also get a thicker gauge of wires for all of this, so it can handle the electricity flow. And I mean, overall, we used a large variety of materials, but we can put more description in that later. But we'll show you a demo too of how it works based on what we got. We have the battery charged, ready to go. And before we start that, we'll just show you. So the 9 volt powers with this. Alright, 9 volt
Right here.
is right there. So it plugs in, basically, you can see that. And then we got this, which is hooked up to the battery. into there. And so that's how it worked. Alright, we'll get back with you with the demo here shortly. Alright, here's our demo. So as you can see, these are some basic things. We can get a little bit heavier, but this is what we got right now. Got an apple. It's pretty lightweight. Probably 20.25 of a pound. Bottle of bills. It's pretty heavy. It's got about 500 tablets. Each tablet's usually about 4 or 5 grams. 3-pound dumbbell. It's a little bit heavier. And pretty full gallon of milk. It's about 5 pounds. I mean, you can see it shook the lamp. And here's the thing. It's already hooked up. Just needs to be plugged in. So it's going to plug in their Arduino. Alright. You can see light. And so these are the battery. So basically we just hook those up just like so. Get them nice and lined up. Alright, now it's ready to go. So we're going to start with the milk. Alright.
Starting from the milk.
See? Just like that. Then it releases pressure and goes down. Alright, now the 3-pound dumbbell. Alright. Then the bottle of pills. And you can hear the servo running. And lastly, the apple. And it's just basically when he releases pressure or moves his finger, the servo stops and he's able to have control. Alright, thank you.